Let's do some advanced factoring involving trigonometry. We want to factor sine squared x minus sine x minus 2. Well, what we want to do is recognize that this is in quadratic form. So it looks a lot like a quadratic function. It's easier to recognize if we rewrite it. So sine squared x is the same as sine x as a quantity squared, and then we have minus sine x minus 2. So it's definitely looking more like a quadratic. And we could actually have gone straight to factoring it from its original form, but I'm actually going to perform a substitution so we can see really clearly how this is a quadratic. I'm going to perform the substitution of letting y, a different variable, equal sine x. So I'm going to replace each sine x with the variable y. So I have y squared minus y minus 2. So definitely a quadratic. A nice one with a leading coefficient of 1, so we can jump right into factoring it quite nicely. We're going to have our two factors that each start with y, and we want two numbers that multiply to give us negative 2 and add together to give us negative 1. So we're going to have y minus 2, y plus 1. And then we're going to return back to our sine function. So we're going to go back and replace y with sine x. So our factorization will be sine x minus 2, and then the quantity sine x plus 1. Let's factor 1/4 cosine x minus cosine cubed x. Each term has a cosine x in common, so let's go ahead and factor that out. I'll have cosine x times the quantity 1/4 minus cosine squared x. And this can actually be factored further. The part in the parentheses is the difference of squares. So 1/4 we can rewrite as 1/2 quantity squared. And then I have minus cosine x quantity squared. So that is perfect for moving forward with the difference of squares. I have cosine x times the quantity 1/2 minus cosine x times the quantity 1/2 plus cosine x. Now let's go ahead and factor sine of 2x minus sine x. But actually, the way this is currently written, I can't factor out anything. So I cannot take out a sine here. So I have two different functions. Sine of 2x and sine x are different. In order to factor, I have to apply the double angle identity here. So I have to rewrite sine of 2x as 2 sine x cosine x. And then I'll bring down the minus sine x. And now each term has a sine x in common. So I'm going to factor that out. And I'll be left with the quantity 2 cosine x minus 1. Now let's factor cosine squared x minus sine x plus 1. And this sort of looks like it's in quadratic form, except the first function is cosine squared x, and then in the middle we have sine x. So we can't have two different trig functions and have quadratic form. So what we want to do is use an identity. We want to rewrite cosine squared x using the Pythagorean identity. So cosine squared x is 1 minus sine squared x. And just like that, we have all the same trig function. Let's combine the like terms. 1 plus 1 is 2. So we have negative sine squared x minus sine x plus 2. Now we have quadratic form. The leading coefficient is negative 1, and I would rather have it be positive 1. So I'm actually going to factor a negative out of all of the terms here. So I'll have negative, and then the quantity sine squared x plus sine x minus 2. And that's going to be a little bit easier to think about in terms of factoring. So I'm going to go straight to setting up the factorization. I'm going to leave the negative out there, and then this is going to factor to sine x and sine x are going to be the first part of each factor. And then I'm looking for two numbers that multiply to give me negative 2, but add together to give me positive 1. So that's going to be positive 2 and negative 1. So now this quadratic form involving trig
functions factored, and then I have this negative on the outside. So that is my final answer.